Does life truly exist on the moon? Is there a gigantic planet filled with living organisms and life forms out there? There are many theories that some of the solar systems have gas giant moons that might be harboring life beneath their icy surfaces. Shrouded in mystery, but yet to come to light, the mysterious Europa, one of Jupiter's biggest moons, illuminates hope for the possibilities of life existing within itself. Containing a tremendous amount of oceanic water, more than that of Earth combined, this beautiful, cracked pattern gas giant might yet signal an existing beacon of life. So does life exist on one of Jupiter's biggest moons? To answer this important question, we'd have to consider tons of realistic reports, research, astronaut sightings, and reports from NASA and other international space bodies. So tighten your seatbelts and pay close attention. We're going to be taking you beyond the world of men. Until a few decades ago, Mars had been the only suitable planet carefully studied apart from the Earth for signs of extraterrestrial life forms. With major international space agencies leading the way, Europa, one of Jupiter's 4 biggest moons, has captured the attention of the whole world. Although the smallest of the 4, Io, Europa, Ganymede, and Callisto, the universe comes with different surprises, but nothing is more surprising and strange than the life forms discovered along hot vents in the unfathomable ocean. As we know, water and sources of energy are the necessary indicators of the presence of life Europa might possess. Therefore, strong tidal heat might keep the inner part of the ocean warm enough to bring liquid water beneath a layer of ice. Therefore, any organic compound would be movable in water, meaning they could interact. If we take a closer look at Europa, the 6th biggest moon in the solar system, and as a possible host of extraterrestrial life forms, we notice its surface is predominantly covered by ice, with its surface looking like cracked glass. Low ridges, straight and curved, bypass the surface, fractures and pits, a frozen and homogeneous mixture, making it stand out as the bright moon. Europa doesn't possess a heavily cratered crust, unlike other moons such as Callisto and Ganymede. These astonishing characteristics make it impossible to determine the age of the moon. As we know, Earth's moons contain many craters. A geologist utilizes this characteristic method for calculating the relative age of a surface, making it impossible to determine the relative age of Europa because it possesses no impact on its surface. Except proven that Europa went through some intense impact throughout millions of years and found a way to erase every proof showcasing any impact. Then it may as well have been lucky throughout the years to have scaled through the different impacts of the solar system with any impact. Could this be true? However, Europa showcases an icy crust that has been intensely broken, as emphasized boldly by the dark, haphazard, curved, and straight bands seen closely on the surface. These broken cracks have divided the crust into plates as massive as 18.5 miles between wedges. The respective areas between the plates are occupied with materials that are homogeneous mixtures of contaminated liquids. Recently, within the last week of September 26th, the world of men made one of the closest but phenomenal approaches by Europa since 1963, leaving spectators watching amusingly. On September 29th, NASA's Juno spacecraft flew past Jupiter's moon, Europa, standing as the closest approach by any instrument worldwide since 2000. The swift flyby was executed with beautifully detailed pictures of the icy surface of Jupiter's 4th largest satellite. NASA's Juno also collected treasure data that scientists will ponder over in months to come to look for signs of watery plumes that may scarcely or occasionally erupt from a gigantic ocean hidden beneath the crust. Although the flyby was supposed to be a surprise, it was also meant to open the doors to many amazing missions to come, most notably the Europa Clipper, which is prepared to launch in 2024. These different missions are meant to be a close-up interaction with Europa to scout for signs of life within and beneath its surface. NASA's Juno spacecraft engagement with Europa was swift and brief. The probe flew past Europa at a speed of 21 kilometers per second, consistently rotating throughout its process. Therefore, in a way, it had to perfectly time its pictures, which had to be clear and perfectly shot at such a speed and rotation. The result presented 4 detailed pictures showcasing the gigantic, ruggedly surfaced world, which is fractured by linear, crater-like depressions. What makes this swift flyby phenomenal? This is because Juno was never meant to study the Europa or as much as fly past it. but rather the instrument was designed to study Jupiter. Juno launched in 2011 and has been ceaselessly flying around Jupiter's surroundings since 2016, acquiring data tirelessly about the planet's clouds, weather, atmospheric components, and its entire proportion, in large part to understand how this massive gas giant was born. Therefore, after decades of concentrating the probe's feedback and investigations on seemingly only Jupiter, NASA's officials decided to give a new directive to Juno, increasing the scope of the mission to now study the moons of the planet. The principal investigator of the Juno mission, Scott Bolton, stated that last year we flew by Ganymede, tomorrow we'll go by Io. Significantly, Jupiter has a stunning total of 80 moons, so what makes Europa special? Well, Europa's vast ocean, arguably and proven to be more copious than Earth's, pinpoints the moon as one of the most astonishing points of research in the whole solar system. Lucas Paganini, the program scientist for the Juno mission, stated that Europa is one of the most promising worlds in our search for habitability and life. So, these missions and their detailed studies are key to shortening the gap between Europa being a promising habitable world and having the data needed to confirm its habitability. Bolton went as far to clarify that oceans are important here, he says, so if we find any, maybe they're important to live with all the time. Definitely, it might seem to a lot that life can come forth without any oceanic body, but if we discover any amazing oceanic bodies millions of miles from other planets, then it pretty much looks like a great time to start searching for life. That's what Bolton suggested. However, we must nevertheless warn you of the ever-existing life-threatening dangers presented by exploring this massive planetary body. There has only been a handful of the flyby of this glassy surfaced moon. The black, icy, and cold depth of the outer solar system takes lots of years to arrive at and stands predominantly as a tremendous challenge for any space probe. But beware, for those daring to journey into the environment surrounding Europa, they must be ready to fight against the belt of harsh radiation that wraps the moon, created by charged particles trapped in Jupiter's strong gravitational field. Not counting NASA's Juno, which flew swiftly past Europa at 352 kilometers. The second spacecraft to have also flown close to Europa was NASA's Galileo, which took place exactly 2 decades ago. Galileo flew past Europa in about 351 kilometers back in 2000, and currently flew at a record-breaking distance of 200 kilometers back in the 90s. Do you know that NASA's Juno has 9 different research tools? Make sure to keep watching to find out more. During this precise but brief flyby, Juno collected data on the moon's magnetic field, gravitational field, and partially non-existent atmosphere of weakened gas. The spacecraft is equipped with a microwave radiometer, Bolton said. We invented it for Juno. It's designed to be able to see below the cloud cover of Jupiter and into the deep atmosphere. But when you point it at an icy body, it sees into the ice at a different depth. Unless the ice is extremely pure and clean, he went on to explain that this tool might not be efficient enough to reveal a global ocean, but it should detect pockets of liquid water closer to the surface. Therefore, much of the evidence emphasizes a movable surface provided by water. Scientists point out that liquid water could exist beneath the surface due to internal tidal heating from gravitational interaction with Jupiter and its 4 biggest moons. Another massive planetary body scientists believe to have some signs of life in it is Titan. The largest of the moons is Saturn. Titan has an atmosphere largely consisting of nitrogen with less than 1% of methane. Considering these, the surface pressure of its atmosphere is higher than that of Earth. The temperature is extremely low. A massive form of organic molecules is found in Titan's atmosphere as a product of the ammonia atmosphere. This discovery has led scientists to raise possibilities of progressive life forms that might truly exist in Titan, although it seems unlikely due to its low temperature. Are we alone in this universe? Or maybe ignorant of life forms that exist millions of miles outside of Earth? We're going to be exploring more of these mysterious discoveries buried in the darkness of the vast space of the solar system in our next video. However, as mankind prepares to venture yet again into the ever-endless but wild solar system of the universe, what do you think? Could Juno achieve any record-breaking speeds in the near future? Do you think NASA can discover another historical life form on missions to come in 2024? Let us know your thoughts in the comment section below.